So today's topic is triangle inequalities, which means we're talking about the side lengths and angle measures of triangles and how they're related. And I've got a couple of little triangles here to help us out. So I'm using some informal language here, but I wanted to let you know the biggest side of a triangle is always opposite the biggest angle. So let's look at our first little triangle here and see if we could figure out which angle would be the largest angle. We'll take a look at the sides and see which one's the longest side. The 10. So since 10 is the longest side, then B is the biggest angle. Could you use the same logic to figure out which angle is the smallest angle? Our shortest side length is 6, that's side BC, and that is opposite of angle A. So angle A will be our smallest angle. And of course our remaining side and our remaining angle would be right in the middle. Now let's look at our other triangle over here. What if I told you that triangle's side lengths are 10, 10, and 20? Would you believe me? Probably not. It just doesn't look right, does it? But also, it's not logically true. It can't be, and here's why. The sum of the two shorter sides of a triangle must be greater than the remaining side. So in this case, our two shorter sides are supposed to be 10. 10 plus 10 is 20. And you know what? 20 is not greater than 20. That's not true. So 10, 10, and 20 could not be the side lengths of a triangle. Nope. Let's choose a more reasonable number. How about 12? That should work. 10 plus 10 is 20, and 12 is less than 20, so that would work. Here's another little triangle. What do you think is the shortest the remaining side could be? 5 is just a little bit too short because 5 plus 5 equals 10. We need the sum to be greater than 10. And 15 would be just a little bit too big because if we add the sides that we have together, we get 15. We need the remaining side to be a little bit smaller than that. So any number between 5 and 15 should work. So you can choose any number between those two and it'll work for this remaining side of our triangle. I'm going to choose 7. Now let's add together our shortest sides just to be sure. 5 plus 7 is 12. Is 12 greater than 10? Yes, it is. So this works. Those could be the side lengths of our triangle. So let's take a look at this problem and see if these 3 segments could make a triangle. Normally you'd have to measure that, but I've already measured it for you. It's 4.5 inches. So remember the procedure we used before. First, we add the two shortest sides. In this case, 1.5 plus 2.5 equals 4. Next, we ask ourselves a question. Is the sum greater than the third side, or is it less than or equal to the third side? In this case, 4 is less than 4.5. That tells us that these sides cannot make a triangle. So no, we do not have a triangle here. So let's read our statements. The first statement says these line segments can form a triangle. Okay, the next one says these line segments can form a triangle. Then we have these line segments cannot form a triangle. Okay, because at least 2 sides of the triangle must be the same length. And that's not why. We can have triangles where all the sides are different lengths. That's not a rule. Okay, let's look at the next one. These line segments cannot form a triangle. Okay, because the longest side of the triangle must be shorter than 4 inches. Yes, that's the case here, because the sum of our first 2 sides, our shorter ones, is equal to 4. Bingo, that one's right on the money. So now you know everything you need to know about triangle inequalities, and you can determine whether or not 3 sides would make a triangle. You can also use the lengths of the sides of a triangle to figure out which angle is the largest or the smallest angle.